Hello, we're T5-CriDomeEngineeringIndustries. My name is Christopher, this is Peter, Justin, and we're doing the expandable spine cage. So our project objective is to design a new spine cage that competes with what's out on the market now while improving spinal fusion and helping people at the same time. So who needs it? Well, first, what is spinal fusion? Spinal fusion is a surgical technique that is used to fuse two or more vertebrae together permanently. So people get this done when they have a lot of back problems. So what kind of back problems are we talking about? Severe back problems such as degenerative disc disease, spine fractures, lordosis, kyphosis, and even tumors. So, what's happening around the world? For the global components, we were asked to find some research that was being done on these expandable cages. What are the best companies for doing these spinal cages, and if there are any other markets around the world implementing these already. So we found some research done by UC Davis, where they took 32 patients, 16 they implanted with expandable cages, 16 with non-expandable. And after a 13-month checkup, the increase in the spine angle was 12 degrees for the non-expandable and 15 degrees for the expandable. So they proved to be safe and reliable, and expandable cages seem to be the better way to go from that study.
One of the companies that are doing expandable cages right now is Globus. They're one of the largest privately manufactured spine companies in the world. So here we have an example of some of the designs for expandable cages, 1, 2, and 3. Another company that's doing expandable cages is Europe also has companies that are doing expandable cages. From Ulrich, which is a German company, they have another version of their expandable cages, and the T5 from Switzerland, which also has the X-Mesh, which is also a type of expandable cage. Now, as with all designs, there are pros and cons. Ideally, you have an expandable cage that has just pros, but obviously there are some design aspects that might be a little negative. For example, the one from Globus, for example, has the smallest inner volume. The inner volume needs to be large in most cases, or as large as possible. That way you can put bone grafts inside of it, and allows for the fusion to take place. The T5 is another one, but again, there's some issues with that one. From the pressure locking mechanism, it tends to not be as durable as the Ultrich system. Next slide, please.
Okay, now since we haven't reached our design portion yet, we have a guideline of how we're going to do it. And what we're going to do is come together as a whole and come up with a practical design, a common one. That's a sliding cage. And from there, we're going to take the pros from each design that we see and mesh them together with that one until we get to the point where we can tweak and move things around to ultimately we'll have a design of our own. Next slide, please. Okay, our prototype will be made out of a plastic using rapid prototyping. So we're going to do the SLA, SLS method, and we chose this for durability and also accuracy. And roughly this is from concept to finished prototype, this is how much it's going to cost. So roughly we're looking about $1,700 for the design validations and intellectual property search all the way to actually making the product. Next slide. And this is the timeline. So by the time we get to, a little bit into April, we should have our design validation going. Next slide. Also, when it comes to designing the spinal cage, we also need to implement the tools needed to place it in the body. So we have to design those as well. And that's where the ethics come into play, because we're also designing things that are for medical, and certain guidelines need to be followed, the FEA, things like that.
Yeah, I didn't see any global perspective on that.
Well, we had mentioned the different companies that are working